I introduced his presentation thema, measuring and dating Vedic text with computational place, algorithmic considerations and the data selection. So please.
Great, thank you, Kyoko. Can everybody see my screen?
Yes.
Okay, great. So I'm talking about quantitative methods for dating texts in Sanskrit and especially in Vedic Sanskrit. And my work is embedded in a new project funded by the German Ministry of Education and Research. And I'm very happy that I could win Sven Selmer and Sebastian Jerich as collaborators in this new project. So my presentation is structured like this. I will first motivate why we need quantitative methods for dating texts, and I will give you a very brief overview of the data that we will use in our project. And the main part of the presentation deals with two different quantitative methods of how we can date texts. The first one is a paper from 2019 that uses neural networks for this task. And the second one is about Bayesian models, Bayesian mixture models. This part may be especially interesting for you because it focuses on Vedic texts. I will present stratifications of the Rig Veda and of the Shaunaka Samhita that are learned using this model. And I will also try to explain which genres are automatically found here and which linguistic features come out to be especially useful when you want to have a look at the diachrony of Vedic. So why do we need quantitative methods at all? We have a very basic idea of the general history of the Vedic literature. However, there are a few reasons, and all of you know them, why our ideas are not very detailed. First, of course, we have no external evidence of any kind, or very few external evidence. Second, Vedic and especially classical Sanskrit are standardized languages, so there's a very limited amount of morphosyntactic development. An important point is also that these texts were composed by an elite of speakers, and therefore they do not reflect many registers and many genres that occur in natural spoken language. And also what I found always very important, most of these texts are presumably compiled from compilations from different sources, from different writers, from different time, and we don't know the exact composition. Apart from this, there are also other factors that somehow hamper our understanding of the temporal dynamics of Vedic. In Vedistic and Indological research, I have the impression there's a tendency rather to concentrate on very rare and very early features. For instance, when you have a look at the literature about Vedic grammar, you find a lot of publications about subjunctives and rare aorist forms and so on. But for instance, much less publications about, let's say, genitive constructions or syntactic developments in later texts. So there's a certain bias in research. In addition, researchers and scholars tend to base their conclusions, text historical conclusions, very often only on a few features or even on a single one. And they also like to look at very small text units. So many of them look at single verses or 2 or 3 verses. And in my opinion, this is not really very meaningful in this content. Also, we see in many Vedistic publications, we see that the authors do not use quantitative methods. They do not use statistical tests of significance and no multivariate methods. And they also do not use corpus-based methods. And finally, I would say perhaps 90% of the work goes to the Rig Veda, and the rest, like middle and late Vedic prose, just only occupies a very small amount of the scholarly work. So these are, so to say, research internal factors. So what should be done, in my opinion, and what are we planning to do in our project? We use multivariate models and statistical tests of significance. This is important. And another important point is we feed in all features and all data we have, and finally let a mathematical model decide which of these features are relevant for our task and which are not. And what is also important, especially in the context of the Bayesian approach, we need somehow a principled and mathematically valid way of integrating results from scholarly works. So this is an important question in my opinion. How can we use all this great work that has been done in Vedic studies and Indological studies for such a purpose, and especially in a mathematical framework? So let me give you a very short and brief overview of the data we will use in our project. Right now, we mainly concentrate on what I would call atomic features. This means simply we use the counts, the frequencies of certain lexical and morphosyntactic features. So for instance, we count how often genitives occur, how often certain words occur, how often subjunctives and imperatives and so on occur. And this is quite obvious choice because we have a lot of databases for this purpose. I just want to mention a few here. We have Veda from Cologne. It's based on the Grassmann analysis of the Rig Veda. Another resource is this one. I really like it, and I think nobody really uses it. Heinrich Hedrich, for his 2007 publication, performed a complete verb argument annotation of the whole Rig Veda. And in a project in Saarbrücken we performed a few years ago, we transformed this annotation into computer readable form, so to say, and you can freely download it here from the Academy in Mainz. Then, of course, I use the digital corpus of Sanskrit. At the time of writing this, we had about 20 Vedic texts in there. I think at the moment, I apologize for not updating the numbers, we have about 30 or 40 texts, and these numbers should also have gone up. So we have somehow a substantial amount of Vedic texts. You can have the database from here. And another point, apart from these atomic features that we want to use in our project, are relational features. So relations between words and their frequencies. And what we will do is we will use syntactic dependencies. We will annotate massive amounts of syntactic structures, really looking forward to it. And there's also a first version of this resource. It's the so-called Vedic tree bank, has been released last year on Hellwig, and there's also a paper describing how you can do it and how it's annotated. And this is mainly done directly in the DCS web interface. So a few words about the quantitative methods we are going to use. There are two main approaches, so to say. One is maximum likelihood. I don't go into the details, just enumerate some advantages and disadvantages. The advantage of maximum likelihood, like neural network, is that these methods are comparatively easy from a mathematical point of view. There are also a few disadvantages. You only get, so to say, point estimates without probabilities, and this is important for philological reasoning. You want to know how probable a certain assignment is in your context. This model also tends to learn noise in the data. This is the so-called problem of overfitting. It's difficult to integrate prior knowledge, which is bad for our purposes, and these models are somehow black boxes, so it's difficult to interpret them and the results. The second big class of models are Bayesian methods, and they maximize the a posteriori probability. The advantage is you get probabilities and error bars for all your decisions, and you can quite easily integrate prior information. These models are less prone to overfitting because you have these priors you can feed in. There are two quite massive disadvantages for Bayesian methods. First, when you have a look at NLP and AI papers, they are rarely among the top rated systems when it comes to precision. And second, they can be mathematically a bit more unpleasant, which is mainly due to this normalizing constant here, this evidence integral. This can be sometimes a bit difficult to evaluate, so you need to resort to approximate methods like MCMC or whatever. A very brief overview of the neural network approach. What did we do there? So, or what did I do there? So the basic workflow is as follows. You get a date range for each text as good as you can from secondary literature. And then you split the text into small text sections, just as Yuki has already explained. You count the features in each section, and then you create two sets, one training set and one test set. And with the training set, you use it to optimize the parameters of the neural network, and then you, so to say, freeze these parameters and use the text sections for measuring the performance of the neural network. So this is has all been described here in this paper, and if you want, you can read it. So which data did I use? I used counts of cases, compound lengths, and so on, part of speech by trigrams. So this means very basic syntactic structures. And on the whole, I got about 1,700 different count features. And I applied this network to the complete DCS. So we got at the end 1,200 training and test sections, which is a really tiny data set from the perspective of machine learning. So I applied this neural network for one interesting question, and this is my data a single text, or is it composed of different strata, which is the opinio communis in the research society. And so I trained a neural network with all texts except for the metadata, and then I froze this network and used the network to predict dates for individual sections of the metadata. And this is what comes out there. So I use it for book 6. Book 6 is composed of three main parts. There's a discussion between King Dhritarashtra and his counselor Sanjaya. Then we have the famous Bhagavad Gita, and then here we have the description of the epic battle. And here are the chapters of book 6, and on the horizontal axis you see the predicted time, and the black line is the averaged prediction of the neural network. And this is quite interesting, I think. For the first part, this Sanjaya Dhritarashtra Samvada, it predicted a quite late time, which is fully in accordance with what you feel when you read the text. And even more important, the Bhagavad Gita was placed in the 2nd or 3rd century CE, which is, I find, quite relevant for text historical research. And then all this battle stuff is placed in the centuries before the Common Era, except for some strange peaks here, to which I will return in a second. So, in my opinion, a quite meaningful result. In the same paper, I used the second type of architecture, the so-called Siamese network, and I will skip all details here and just say such a Siamese architecture, in my case, just had to decide if two text sections are contemporaneous or if they are not. So you feed into the features of two text sections, and then let the network decide were these text sections written at the same time or not. And when you apply this network to the book 6, to the 6th book of the Mahabharata, again, you get out this. Here on the horizontal axis, you again have the chapters of the book. And what is interesting here are these vertical dark lines. And these dark lines basically mean that the respective chapter was labeled as being later than the rest of book 6. And now it's quite interesting when you look at the actual chapters, what's written in there, you see that these chapters describe the nights between each day of the battle, and these nights are marked here with these triangles at the top. So one way to interpret this plot is to say that perhaps the whole battle description was one old text, and a later generation of authors just inserted these descriptions of the nights between each day of the battle, and thereby created a somehow composite text. Let me come to the second part of my presentation. This first one was about maximum likelihood approaches with all these disadvantages that they can have. In the second one, I will introduce the Bayesian methods, and what we use here in our project is a so-called hidden variable model. This model performs two tasks at the same time. It induces a temporal structure of a text, and at the same time it should, or it can tell you which linguistic features are most useful for inducing such a temporal structure. One thing a neural network cannot easily do. So Bayesian methods or hidden variable methods consist of three elements. First, you have the observed variables in green. These are counts of linguistic features in our case. Then you have prior knowledge information induced, for instance, from secondary literature. This is in blue. For our case, it's basic temporal information or temporal ideas about when certain texts were perhaps written. And then third in red, you have the so-called hidden variables, and this is what you're actually interested in. After this model has been trained, these hidden variables should contain the, so to say, true dates of each text section. At the same time, there are some confounding factors. For instance, linguistic distributions may not only be caused by time, but they are, of course, also caused by social linguistic factors, by geographical factors, and so on. And these factors are subsumed in this model under so-called background distributions, and the model decides automatically for time or background, and then should produce a good prediction of the time. So, sorry, something went wrong. This is roughly said the mathematical background for those of you who take pleasure in plate notation. This is a plate of this model, and as I said, the inference in this model and learning such models can be a bit more demanding. So you finally have to resort to approximate methods. We use here a Gibbs sampler, a collapsed Gibbs sampler, but you can also use variation inference or whatever you like for this task. So which data and priors did we use? I use priors that basically, temporal priors that basically go back to publications by Michael Witzel. And so I assigned each text to one of 5 layers of Vedic literature and extracted from his work some very approximate time ranges. And please keep in mind, these time ranges are not meant as true dates, but rather as a first idea to give to the model when certain texts may have been written. And for features, I used those from the neural network paper, and I also removed duplicates, this means cited stanzas with Bloomfield's Vedic concordance. If you need these data, they are also found on in my GitHub repo. So what comes out when you apply such a model to the Rig Veda? Here on the horizontal axis, you see the individual books of the Rig Veda. Book 1 starts here, 2 starts here, 8, 9, and 10. And the vertical axis gives the predicted time. the use in the main plotting area indicate how confident the model is about certain predictions. That's one of the big advantages of Bayesian models. And the black line is again the averaged mean time. And one has to say that the model did not have the information that book 10 may be later than books 1 to 9, but it just got one uninformative prior. So what comes out here are two things. First, we see that 8 and 9 are seem to be somehow earlier than the rest of the text. Book 10 is placed quite clearly, significantly later than the rest of the text. And in between, what's also interesting, but what I have to skip here today, you see some peaks. And these peaks mostly occur at the end of each book. And here at the bottom, you see these tiny red lines. And these red lines correspond to Oldenburg's appendices to the Rig Veda, according to his opinion. And you can, if you are in the mood for doing it, you can perform statistical tests of significance, and they show that according to this model, Oldenburg's appendices really seem to be later than the rest of the text. You can also try to compare the results of this model with previous scholarship, and basically what I did here, I took the predictions of the model for each book and then performed statistical tests of significance between the predictions for each book and used these tests as ordering constraints. The details are found in the paper. And using these ordering constraints, I reordered the whole Rig Veda, and what comes out is seen here. Book 4 and 8 seem to be the earliest books. Then in between you find the remaining family books, and book 9, they are somehow in between the oldest and the latest layer, and the latest layer is very clearly marked by book 10 of the Rig Veda. If you repeat this test with a minimum location shift, I skip the details, so to say, classical ordering of the Rig Veda comes out. So 1 to 9 seems to be earlier than book 10. Of course, for anyone who works in the field of Vedic studies, this result is definitely not surprising. I nevertheless find it interesting because such a model without any prior knowledge can by itself detect such an ordering without further outer input information. So a second text, I'm currently working on the Papalata recension of the Atharva Veda, and therefore I had a look at the Shaunaka recension, and Whitney and Landman in their translation of this work splits the whole text into 3 so-called grand divisions. These are books 1 to 7, 8 to 12, and 13 to 18. And later on, Michael Witzel somehow agreed with the split, and he also added a temporal component saying that 1 to 5 may be earlier than 8 to 12, and again earlier than 13 to 18, and 6 to 7 seem to be interpolations. So what comes out when you apply such a Bayesian model to the Atharva Veda? You get something like this. Again, the books are on the horizontal axis and the times on the vertical axis. So 1 to 7 are assigned to quite uniformly to a quite early time range. And then the temporal predictions go up for the later books. So there seems to be some truth about the split into 3 grand divisions. You can also do, again, statistical tests of significance, and they more or less confirm the theory proposed by Witzel that really the first grand division seems to be earlier than the second, and again, earlier than the third one. So I mentioned very briefly that we have these mysterious background distributions apart from the temporal distributions, and I wanted to find out what these background distributions really capture, which kind of linguistic variation do they capture in such a model. So I calculated their pairwise Euclidean distances and used these distances as weights in a graph. And when you feed this into Gephi or any other graph visualization software, you get out this plot here. I think maybe a bit too small, but hopefully you can see it. So what's somehow automatically and in a very unsupervised fashion captured in these background distributions seems to me to be a kind of genre distinction. So you have here very close in this graph all these metrical texts and the metrical parts of the early Taitiria, of the early Veda Sanitas, sorry. Then here at the left, you have all prose words, and in the middle, these are the Grihya Sutras, and interestingly, in between, we have the Upanishads that seem to be at some kind of intermediate position between Grihya and these early prose, early and later prose. Also, one more detail I would like to mention here, these models, as I said, can tell you which features can be useful when you want to work about specific periods of the Vedic language. And this is what I tried to plot here. We have 4 plots. In each plot, the horizontal axis is again the inferred historical time, and the vertical axis shows a measure indicating how useful a certain feature is for distinguishing texts in a certain period. So this, for instance, means that cases, nominative, accusative, and so on, are quite useful when you work with comparatively early texts. And the same is true for tenses. So tenses are rather concentrated here in the left part of the plot. So both case information and tense information seems to be useful when you want to work with early text, when you want to tell something about the chronology of early texts. It's completely or quite different for later texts. When you have a look at the 2 bottom diagrams here, you see that both the lengths of compounds and part of speech trigrams rather concentrate on the right side of the plot. This means in the later Vedic phase. And in my opinion, this can be interpreted as follows, like when you want to work with later Vedic texts, when you want to study, for instance, the historical development of Grihya Sutras and late or early Upanishads, you should rather concentrate on such syntax-related features. So 2 slides to sum up my presentation. In general, what should we do in text historical studies? One important point is we should choose sufficiently large text sections, or let the model automatically decide where a section ends. So there are very nice models like hierarchical Dirichlet processes that can do all this by themselves. And at least I will try not to report results for individual strophes because they're mostly not meaningful. Secondly, we should use statistical tests of significance when we compare results, and we also get out very nice stuff with comparatively easy methods. This will be done in one paper that comes out hopefully later this year in JROS. We should use multivariate data and use multivariate methods. And also we should try to let the data tell us which features may be relevant and which may not be so relevant for our task, instead of imposing our own ideas about the development of Vedic linguistics. And regarding the model that, and especially regarding the Bayesian model I presented here today and what we are going to do in our project, the main areas of applications are, from my perspective, the stratification of the Vedic literature. I hope we can get interesting results out of it. Second, I would like to concentrate on detecting linguistic features that have an interesting, so to say, diachronic distributions. And I hope we will get interesting results here for the development of Vedic syntax. hopefully. And what I have in mind is somehow unconventional workflow. Let's say we use an initial model, let the model detect interesting patterns, interesting structures in certain texts. Then we write a short philological paper discussing these results and trying to combine them with previous scholarship. And then we can adapt the model and adapt priors, retrain the model and detect new interesting patterns. In this way, we refine the dating of the Vedic corpus. And of course, what's also important, I mentioned very briefly, by now we only have this very generic background distribution. And what we want to do is we want to make this much more fine-grained by, for instance, by integrating geographical priors from secondary literature, or for instance, also prior knowledge about genres. And this will also be one of the key areas of this new project. So thank you for your attention, and yeah, that's it.
Thank you very much for your excellent presentation. Does anyone have comment, questions? Takahashi-san, yes, please.
Hi, this is Kenji. Thank you very much for interesting talk, and it was very fascinating. And if I understand very correctly, this is your dating is based on the assumption that all the text occurred in one place, right? So if I understand correctly, but I think that Amano-san's plan is to locate the text, so the geographical differences. So I think that is there any ways to incorporate these geographical differences into this time span and the text, or is there any ideas, or your present model also have some facility to incorporate these informations?
As I said, let me open one previous slide here. So it's sorry, I should have given an explanation here. But basically, right now, the model is like, here is the hidden temporal variable, and this is the temporal prior. And currently, we only have this branch here and this branch for the background distribution. And of course, nothing prevents us from extracting, and that's what we are planning to do. Nothing prevents us from extracting temporal prior information, take them as, so to say, semi-observed, and add another branch here that either samples features by temporal information, or by geographic information, or by social linguistic information, whatever. So this is one of the fields we want to go in.
Okay.
I hope this could answer your question. I'm not sure. But...
Okay. That's a precise clarification. I understand. Thank you.
Thank you.
Yeah, Tiziana, you have a question.
Yes, thank you so much for this momentous presentation. I just to ask for repeating something. Be so kind, please, to repeat, to explain once again what you presented about the chronology of the Atharva Veda after projecting the slide about Whitley, Landman, and Witzel evaluation. You explained something else, but I didn't catch you. I'm sorry. Thank you.
Oh, yeah, sorry. So I suppose this was the second part, like, hope until this point it was clear. So we have quite early dates for 1 to 7, and then the dates seem to go up for 8 to 12 and for 13 to 18. Did you follow to this point, or was it already too fast? I don't know.
The last 3 lines in the slide, in fact.
Oh yes, yeah. This is something I had to skip for lack of time. So this was mainly where some examples where these peaks occur here. These are just to show to which chapters these peaks occur, and these seem to be quite late parts according to my model of the Shaunaka Sanhita.
Great. Okay. Thank you so much.
And Tyler, you have a question, please?
Yes, so Maria Piera from Pisa. It's just, I mean, I never studied this kind of question, so it would be quite a general question. But my doubt is that a model like this may work very well in case when your language, the tokens of language you are studying are everyday language. I mean, where the person who is speaking is not working on the language she or he is using. While here we have with Rig Veda, Atharva Veda, etc., a very special kind of language where the poet himself works on what he uses. Do you think you will have to adjust something to account for this, or simply the high numbers may help you in avoiding poetry as a noise?
Yeah. So basically, I think this is, if I got the point you want to make, we are basically talking about Sanskrit or Vedic Sanskrit as a standardized literary language. So, and of course, we have these poets were very keen about choosing special terms, special expressions that are not everyday language. And I think this is exactly one of the points why dating these texts is so complicated and why we need large samples. And my personal conviction, so to say, right now, I have only indications that it may work, but my personal conviction is that when we use large corpora, we can nevertheless find enough changes to correlate them with time. But of course, this language is standardized. This language is not everyday language. It does not evolve like everyday language. So I fully agree with you. But it's complicated.
Okay, so you rely on high numbers. We have to rely on high numbers of tokens to...
I think so, yeah. And especially, let's see what comes out, for instance, from the syntax. I think this is a really unexplored area so far, or only with very few very specialized publications, mainly focusing on the Rig Veda. So you never know. Changes, for instance, in the verb-object position, changes between, let's say, Brahmana prose and Kritya Sutra prose that have not been detected so far. And I'm quite confident that we will make some or we'll find some new ideas there.
Thank you.
And Tyler?
Okay, thank you. Thank you, Oliver. So my question is also about sort of the nature of the literature or the text that we're working with. You mentioned that you've been focusing on composite texts and, working with dating and layering of texts. This is, of course, the more relevant thing to do. I myself tend to work on works of a single author, yet they also have their own compositional structure when they're quoting other authors. So actually what my interest would be is to hear what other recommendations you have for people who don't work on dating in particular, or who don't work on compositional text or Vedic text in particular. Are there general pointers you can give for those who are interested in the principles you outlined about being more quantitative in doing this kind of work? Because obviously many Sanskritists don't have a background in statistics, but are there example, I mean, your work is also obviously worth reading through, but are there other examples or other resources you would recommend to the audience about how to apply these same principles, whether or not we're working on dating or composite texts in particular?
So basically, I think one very interesting point apart from dating, really, and if you want to stick to a Bayesian framework somehow, is really what was mentioned by Yuki, these LDA models. So in my opinion, we still rely by far too much on some kind of manually selected or personal ideas about what was written, what was written in which texts, and these models, and especially if we somehow adapt these models, could really make an overview about the content of Vedic literature, of Sanskrit literature, much easier than it is today. So I think personally, if I would not do dating and stratification, I would certainly go into this content direction and see how we can get a better overview, or find, for instance, finding passages where people talk about the same thing, short passages. Of course, we can use something like Yuki has shown, sums of Pareto vectors, but I think this is a really interesting area that needs much more research by now, and which can really bring forward the field in some way.
Okay. Then the time is now over, and Sebastian, can you ask your question later at the discussion? Yeah. Okay. So thank you very much again